On the basis of that, there are two types of the polymerization reaction. First one is the addition polymerization, which is also called as chain growth polymerization, condensation polymerization, also known as step growth polymerization. Let us learn first of all addition polymerization, which will give you obviously the addition polymer or chain growth polymers. In this case, the monomers of the reaction involved are unsaturated compounds like alkene, dienes and their derivatives. The addition reaction which is involved in this polymerization reaction involves a free radical mechanism. The intermittent species or the reactive intermediate involved in the mechanism is a radical, free radical. Apart from the reactant or apart from the starting material which are acting as the monomers in this case like alkenes and dienes, another important substance or another important part of this reaction is radical initiator, which is nothing but the catalyst for this reaction. Examples of radical initiator are benzoyl peroxide, acetyl peroxide, tertiary butyl peroxide, etc. Let us learn the mechanism of this addition polymerization of, we will take one example for the preparation of polyethylene by using the monomer ethene. It involves three main steps. First one is the chain initiation, next one is the chain propagation and the last one is the chain termination. The first step, chain initiation, here the role of benzoyl peroxide or any radical initiator is very important. This radical initiator is going to initiate the reaction, that is it is going to create the radical or free radical which is required for this reaction. We can see the first step in detail with the mechanism here. This is the structure of benzoyl peroxide. In a peroxide, there is always a peroxo linkage. Peroxo linkage is the linkage in between oxygen to oxygen by a single bond. You can see the reaction which is involved in this first step is the homolysis or homolytic cleavage is involved in this. Homolytic cleavage is shown by the half-headed arrow like this, which is going to yield the radical or free radical due to the equal distribution of the two bonding electrons, that is each radical will get the single electron which is called as the free radical now. So, we are getting here the benzoyl free radical in which single electron is present on the oxygen. This benzoyl free radical will lose the carbon dioxide molecule and will generate two phenyl radicals. These phenyl radicals are going to attack on the reactant, that is an alkene, ethene in this case, and we are getting a new radical in which the phenyl group is attached to now the ethylene group. After chain initiation, that is chain is initiated, the radical is synthesized. The next and very important step is the chain propagation, in which the chain length is elongated by addition reaction in between the radical and the new ethylene or ethene molecule. We can see in the form of this image, this is your radical which is initiated or which is generated in the chain initiation step, which will attack on the another molecule of ethene, giving rise to the another free radical which is now having total 4 carbons apart from the phenyl ring. So, if we are going on repeating this step for multiple times or n times, we are getting such a radical in which there will be n number of carbon atoms in it. That is, we are simply elongating the length of a polymeric chain, which is nothing but the chain propagation step. Chain propagation step, it is very important. It will give you the desired length or desired mass of a polymer. But once we have get the desired length or mass of a polymer, the chain propagation step should be stopped. That can be done in the chain termination step. In this step, we are going to stop the polymerization reaction, we are going to stop addition reaction by using these steps. We can see when we are reacting the two radicals with each other obviously they will undergo the reaction giving rise to a bond in between the two radicals, and this is how we are going to end the chain reaction, that is chain propagation reaction is terminated in this way. That's all the mechanism for addition polymerization of ethene giving rise to polyethene.